Good afternoon, Shruti, Vishal, Kanishka, Divya, Sharmila, Lokesh, Rahul, Ashwin, Ekta, Darshani, Naresh, Avinash. Good afternoon, beta. Sorry for late, beta. Seventh class, beta. I teach from 9th class. Rajesh, good afternoon, beta. Oh, sorry, Rajesh, good afternoon. Yeah, I'm not well. I'm still having fever. Yeah, what to do? Health is not well. Yeah, still fever is there, cough and cold is there. It will be subsiding. It will take some time, I guess. So now we were talking about potential energy. Just trying gathering myself. So last class we were talking about kinetic energy. We did some numericals also. Medicines I'm taking continuously. Medicines taking. I'm under medication only. So now last class we were talking about potential energy. In that we learned what is exactly called as kinetic energy, and then today we are going to understand potential energy. One question I have asked from you all about watch, and I was talking about spring. Then when can a body have both kinetic energy and potential energy? Means you know that energy is something which is exactly possessed in a body, and this energy is making you capable of doing work. So now work can be of many different types. Work can be of many different types. Some work we can be able to say by force into displacement, where you are applying force and you will have displacement. That time it will be exactly said to be like a pure work done according to physics. But some work will be there which you cannot be able to say that yes, it is 100% going to get converted into what you called work. Physical content will be there, but after that like an external force will be applied. But rather than converting that external force into displacement, there will be change in the configuration of the body. Means the shape and size of the body will change. Or sometimes after applying external force, the body the body will have the body will be using that force for what you call further usage. So that means in a way that is stored in the body. So we already know that there are two different type of energy. One energy will be called as potential energy. Another energy will be exactly called as kinetic energy. Okay, the speed of the watch will decrease in space. Yes, beta. But no, exactly time will be slower in space. So your earth time 1 year in space will 1 hour in space will be 7 years on earth. So earth means how many, that's why the astronauts age will be exactly moving slower in space in compared to that of earth. Aging will be slow in space. That is a different thing. Watch, I was asking about that, watch will be moving faster or slow. Then watch will move fast because one factor is there, that gravitational effect of a planet reduces the speed of the watch. The gravitational effect of the planet, yes beta, time dilation concept is there. Yes, time dilation concept is there. Theory of relativity is also there according to Einstein. So there are many factors there. But one very important point there is कि when you will take your watch in space, where your watch will be moving faster, because the speed of the watch will be exactly slows down according to the gravitation of the planet, So this is exactly one of another important factor. I hope you might have understood this point. This is another important factor. I hope understood this point or not. So now I'm going to go back towards the content. Okay, Shruti, understood? Okay. Inform everyone to join, because after this explanation I am going to give numericals. Today also numericals we are going to do. Okay, understood now? Because I have to finish syllabus and full on term 2 revision I have to give. I cannot stop myself from giving revision, asking questions and taking sample paper examination. Whatever will be the condition, examination and everything will be there. Fine. So now hi Satyashri, hi beta. Sorry, today health is really not in good condition. I'm coping. Won't be able to wear specs. It's again creating problem. Now look at so now potential energy, the next important type of energy what we are going to see here is potential energy. So when work is done on a body by force and the body does not move but changes its position or configuration shape, then the work done on the body gets stored in the form of energy called potential energy. This is a very important point. I want everyone to understand this point. And that is this point is a very important point. That is, when a work is done in a body, I told you कि when you have exactly applied force on a body, that is in the form of external force, and the body will have displacement. So when you have applied a force and the body will have displacement, then you will be saying that work is done. Then in letting the body go from one place to another place, okay, by application of force. But what if you have given energy to a body and the body will have energy in the form of external force you have given to the body, but that external energy in the form of force the body will take, but rather than doing displacement, the body will change its shape or configuration. Okay, I'm repeating, the body will change its shape or configuration. Then then the work done on the body gets stored in the form of energy. The work done on the body gets stored in the form of what? The work done on the body gets stored in the form of energy, and it is called as potential energy. Okay, it will be exactly called as what? It will be called as potential energy. I hope you might have understood this point. So whatever energy will be stored in the body, that energy will be exactly, rubber band is also one of the example. Rubber band is exactly one example, beta. We can take that one. Very good. So Ashutosh, understood? Hey Ashutosh, what happened to you, huh? Why you are crying? So it is stored in the form of energy called as potential energy. I should be crying today. Balloon is an example, yes. Yes, you can take the example of balloon. Okay, fine. Shall we go back to the next one? What is exactly next important example we can say? Can you give me some examples of potential energy? Come on, give some examples of potential energy. Now, like I'm taking one example, slime. Slime example. Now, give the full content related to it, Ekta. Slime full content give. Rightful about slime. What you want to say about slime? Simply you told. Old objects up to ground. Okay, so when you are taking the example of old object up to ground, means when you are taking an object to a ground or certain height, that time the object will be having a type of energy called as gravitational potential energy. That will be exactly called as what? That will be called as gravitational potential energy. That time that energy will be will be called as gravitational potential energy. That time I'm just repeating it again and again. So now let us see one example. I think my example is based on that point only. So holding object up on the ground will be exactly, the object will be having what type of energy? Keshav, gravitational potential energy, because here the work done is against gravity, because each and every object will experience a force F will be equal to mg, and when you are taking the object to a certain height h, that time the body will have a potential energy that will be called as gravitational potential energy. I hope you have understood this point. The body will have an energy that will be called as gravitational potential energy. So now consider an object, say a football. Consider an object, say a football, lying on the ground. Suppose work is done on the football to place it on the tabletop. This work done is stored as gravitational potential energy of the football placed on the tabletop. So thus football as potential energy due to it, football has potential energy due to its position with respect to the ground. Due to its position with respect to the ground, that will be exactly called as gravitational potential energy. Okay, so ma'am, in olden days, they use what for fighting? I don't remember name, ma'am. In Hindi it is dhanush. Yes, I think yes, dhanush means in Ramayana, in many Mahabharata, I think you might have seen that that bow and arrow will be there. So they will be stretching the arrow, the bow will be tied on that, and they will be stretching it. So in a way, that string will be there. It will be storing the energy in the form of potential energy. Yes, bow and arrow. They will be storing this energy in the form of potential energy, and then the moment it will be released, it will be having kinetic energy. The moment it will be released, it will be exactly having what type of energy? Kinetic energy. I hope you might have understood this point. Forgive me. Is there any change in my voice quality? Am I audible nicely? Any change in my voice quality? Any problem is there? Fall body have kinetic energy. Yes. Storing the body up on the ground is exactly having potential energy. Yes. Okay, shall we go for the next slide? So what is gravitational potential energy and elastic energy, beta? So there will be two different type of energy. One will be called as gravitational potential energy. Another one will be called as beta elastic energy. So now we know that one ball I am going to take from the ground, and I'll keep that ball on certain height. Then the ball will be storing an energy that will be due to its height on the ground, and that energy what the ball is storing is called as gravitational potential energy. What energy? I'm audible now, beta. Thank you so much, because I am itself feeling my voice is different, or my ear is not hearing my voice nicely. Everything gone. So that means exactly it is called as what? Gravitational potential energy. Take a book and keep it on certain height. The book will have what? At certain height, because it is work done against gravity. Whenever you are holding, you are keeping something from ground and keeping it in certain height, that means work is done against gravity. And in the same way, when you will throw something on ground, it is work is done in favor of gravitational pull. So the object will be like, you don't have to throw it, you just have to release it. So once you will release it, it will automatically come on the ground. Once you will release it, it will automatically come on the ground. So it will be exactly considered as what? Gravitational potential energy, when it will be kept at certain height. And when you will release it again, it will come in motion. It will have kinetic energy. It will come in motion. It will have what? It will have kinetic energy. Okay. So that means the energy of a body due to its position or change in shape is called as potential energy. So the due to position or change in shape means it is exactly called as potential energy. This is the definition of potential energy. This PDF will be available to you. So actually the energy of the body due to its position above the ground is called as gravitational potential energy. From the beginning part of the class I kept on talking about it. So I hope you might have understood. You keep things again to a certain height, it will be having what type of energy? Gravitational potential energy. Now next is exactly another one is elastic potential energy. Elastic potential energy, I think Ekta was talking about rubber and string. So if I am going to take bow and arrow, I think Kesha was talking about. So that bow and arrow na beta, that is also coming under what? It is exactly that bow and arrow now. So once that arrow I think it will be stretched back to the string, it will be exactly called as the energy will be stored in the string, and then when you release it, it will get converted into kinetic energy. So that bow and arrow will also be having that. So that is called as elastic potential energy. Rubber, bow and arrow, steel, they all will be having what? Elastic potential energy. They will have what? Elastic potential energy. I repeat, they will be having what? Elastic potential energy. What type of energy they will have? Elastic potential energy. So now I guess you might have understood gravitational potential energy, and you will be able to give the example of gravitational potential energy, or you will be able to give the example of spring. Beta, correct only Naresh. Spring is again an example, or you can give the example of rubber or string, or what you call spring, and that coil, all will be exactly having elastic potential energy. Now next we are going to understand about mechanical energy. So what is a mechanical energy? So you have to understand that some body may have both kinetic and potential energy. Some bodies will have both kinetic and potential energy. That energy will be exactly called as what? Mechanical energy. A man climbing a hill, so definitely he is exactly going on certain height. So he is exactly not on the ground. He is doing work against gravity. So he is at certain height. The first thing, potential energy is stored, and since he is in motion, so kinetic energy is also there. So 100% this will be exactly a type where both kinetic and potential energy will be there. Again, a bird flying, again the bird is exactly at certain height. So since the bird is exactly coming into the bird is at certain height, so it is exactly both having kinetic and potential energy. A flying aeroplane is also having both kinetic as well as potential energy. Whenever an object is kept at certain height, yes beta, man, vehicle, engine, car, when they will be at motion, so yes, the fuel will be exactly present in the vehicle, and it will be exactly stored as a potential energy when it will have combustion, and when ignition will be there for the fuel, and then the body will have motion, so that potential energy will get converted into kinetic energy. Super. So a man climbing in a hill, a flying bird, a flying aeroplane, all have potential energy as well as kinetic energy. The sum of potential energy and kinetic energy is called as mechanical energy. So already I have discussed the sum of potential energy and kinetic energy. Means if I am going to add potential energy and kinetic energy, that together it is exactly called as mechanical energy. Can you repeat what is mechanical energy, anyone? What is mechanical energy, beta? What is mechanical energy? We'll go to next slide. The sum of the sum of say yes, ma'am. One doubt. Ask Vishal. Sum of potential energy plus kinetic energy is exactly called as mechanical energy. Yes, Avinash correct, after that Keshav correct, Ashwin correct. Yes beta, sum of potential energy and kinetic energy will be called as mechanical energy. Okay, potential and kinetic energy will be called as mechanical energy. Satyashri absolutely correct beta, potential energy plus kinetic energy will be exactly called as mechanical energy. Super. So now we will go back to potential energy. How many types of potential energy is there? First is potential energy due to position, and second is potential energy due to configuration. Okay, so there are two type of potential energy. Ekta, body having both kinetic and potential. Absolutely correct Ekta. Vishal, when ball falls from a height, it has both kinetic and potential. Whatever potential it has stored, accordingly it will have kinetic energy. Okay, so yeah, I told your point, Vishal. So whatever potential has been stored, accordingly it will have kinetic. So now that means what na beta, you have to understand one thing. According to the mass and mg, force mg into height h, whatever potential it has, accordingly it will have kinetic energy. So now potential energy is of two type. One, how many type of potential energies are there? One due to its position, one due to its configuration. So Vishal, your example for the first one will come due to its position, and configuration means according to its shape and size. Okay, that configuration will be exactly. So first we are going to talk about potential energy due to its position. Which and all examples we can say where the potential energy due to its position we can check. The potential energy due to its position we can check. I have just compiled the most important points for you, so that in examination when questions will be coming, so it has mechanical energy. Yes beta, it will have, the body will be kept at a height, and from there if you are releasing, so it will have both potential. So always the mgh will be conserved there. I'm going to explain that conservation also, that from that point you are keeping at a height to certain distance to fitting on the ground, all it will be exactly coming as mgh. That point conservation I'm going to explain. Okay, I'm going to prove that point also. Don't worry about those things. I never keep things half. I'll explain everything in perfect time. That time also beta, you will be able to understand. Okay, so now look here beta, how many types of potential energy is there? Come on, tell me beta. If you want, if somebody will be asking you how many types of potential energy will be there, what answer you are going to give? How many types of potential energy is there? Just answer the question, how many types of potential energies are there? So Ekta, two types are there. Very good. What and all are there? What and all are there beta? Just tell me. Two types of potential energy, what are they? Two types of potential energy, what are they? Come on, quickly tell me. One is potential energy due to position, and second is potential energy due to, so potential energy due to potential energy due to its position. Second one, absolutely correct Shruti. One is potential energy due to its position, second is potential energy due to its configuration. These are the two different type of potential energy. One is due to position, second one due to configuration. Yes, absolutely correct beta. Now let's see examples of potential energy due to position. Examples of potential energy due to position beta. Fine. So now let's see some examples. The water in a tank on a roof of a building possess potential energy due to its position, height above the ground. Yes beta, you might have seen that in every building you will be seeing a tank will be there. In that water will be stored. In every building you will be seeing one tank will be there. In that in dams also you will be seeing that water will be stored in one place, and then it will be released time to time. So what is exactly that stored water is exactly a type of potential energy will be there, and then that potential energy will get converted into kinetic energy. So that stored water will be exactly at a certain height, so that stored water is exactly potential energy. Okay, so the water in a tank on the roof of a building possess what type of energy? Potential energy due to its position. Potential energy due to its position. Yes beta, cylinder example also you can take. I'll explain that one. Next is a lifted weight, as it can do work when it fall down under gravity. Yes, so when a man will be carrying certain weight on his head, So definitely it is, the weight is exactly to certain height h, so that will come as gravitational potential energy. And Vishal, I think you will be getting the answer, potential energy due to its position, in that the moment you will exactly throw it again, then it will have kinetic energy. So right now if I am keeping a heavy weight on my head, I will have potential energy, the object will have potential energy, the object will have potential energy. See, a lifted weight, as it can do work when it falls under gravity, falls down under gravity. So I just took some weight on my head and I am standing, and after that I am going to throw it down. So if I am taking some weight on my head and then I am exactly throwing it down, so now it is doing work. Yes or no? So the stored weight on my head is a type of what? Potential energy. And when I am lifting it down and when I am throwing it down, it will get converted into kinetic. So water stored in a dam has potential energy due to its position. The potential energy in the stored water can be used to generate electricity. Now you can see here potential energy example. You can see that the water in the tank on the roof of a building possesses potential energy. Now height, when it will be exactly, so see, this potential energy will get converted into kinetic energy, and that's why with pressure the water will be exactly going down. The pressure, with pressure the water will exactly go down. Now another example, a lifted weight, as it can do one work when it will fall. So now you can see this one, you can see this one, the lifted weight. So you can see that the weight is exactly here. So it's because of background black, you cannot be able to see. If you can see that, okay, wait, okay, so this is the lifted weight. So you have exactly lifted the weight. Now the moment you are going to release it, it will go down. Okay, so according to its height, it will have a potential energy called as gravitational potential energy. Vishal, come on, quickly tell me, did you understood this one? Did you understood this point? Did you understood this point, Vishal? I told you at the time when I will be giving examples, you will understand this one. Understood this point, beta? Now another one is potential energy examples if you want to take. Now you see the dam construction one. So the water will be exactly stored in the reservoir, and then with high pressure the water is exactly allowed to go down, and it will be exactly connected to the turbine. It will rotate the turbine. The shaft connected to the turbine will rotate. It will connect it to the dynamo, and then it will exactly store energy, okay, in the form of electricity. Now you understood na beta? And this is exactly in the way, and then it will come out as reverse stream. So that means potential energy will get converted into kinetic energy, and we can use this for construction, we can use this for formation of electricity. Yes, this example I am repeating one more time. Which example you want me to repeat? Previous example. See, look here, I just lifted one previous example. I just lifted one, you can see this one. So one object is there, you just keep at certain height. So this from the ground, it is at height h. So definitely mg will be acting down. Mg will be acting down. So you know work done will be exactly here. mgh, force into displacement. Now here displacement is exactly, force is mg and displacement is h. So mgh, work done is exactly here mgh. So it is stored. So it is stored in the it is stored in the form of, it is stored what? It is stored in the form of potential energy. So it is stored in the form of what? Potential energy. Keshav, I hope you might have understood this point. Quickly say. mg, height h, work done, mgh. Come on, quickly say so that I can go to the next point. Understood, Keshav? Now next one was dam construction. We were discussing about construction of dam. In that also you can see that water stored in the reservoir was in the form of potential energy. When you will release the water, it will pass through the turbine and it will exactly have kinetic energy. With that energy, it will be able to rotate the blades of the turbine is connected to shaft, the shaft is connected to dynamo, and it will be storing energy in the form of electricity, in the form of electricity. So generation of electricity can be done with that example. Now next, another example is this one, that is potential energy due to configuration. Last class I was talking about spring coiling and uncoiling. Spring coiling and uncoiling, I think the same time I started with this example, I was discussing about I was discussing about one very important point that time. I was discussing about that how this spring will be exactly utilized for rotation of minute hand and hour hand. Then we came into conclusion that the spring will coil or uncoil itself, and because of that the minute hand and hour hand will rotate, and because of that only we can see motion of the minute hand and hour hand in watch. But this coiling and uncoiling will bring a situation when energy one time will be stored, and that energy which is exactly stored will become potential energy. And when it is uncoiling itself, when it is coiling, it is a storing energy in the form of potential. But the moment it will start uncoiling it, at that particular moment it will have kinetic energy. At that particular moment it will have what? It will have kinetic energy. This is a very important this is a very important concept. Okay, so now just a coiled spring in case of watch, a toy or a gramophone, they are, when the coiled spring uncoils, come on, okay. When the coiled spring will uncoil, it does work by rotating the hands of the watch, setting the toy in motion, or rotating the gramophone disc to play. So this is what Ashwin, I'm going to repeat. I just yes, Ashwin, I just told one thing. If you will coil it, it will get coiled. So one time will come when the spring will be exactly coiled, and it will be connected to some screw, like rotating wheels will be there. So the coiling and uncoiling of the spring will allow the minute hand and the hour hand to rotate. Okay, so this will be exactly due to, so when it will coil, it will store energy. So that time it will have potential. When it will be exactly uncoiling it, that time it will have kinetic. So coiling and uncoiling will create a situation when the one time energy will be stored and another time stored energy will be utilized. So that's why it is called as potential energy due to configuration. So potential energy due to configuration says that when you coil spring, sometimes some toys will be there, na, you put a key in that toy. So why you are putting key in that toy? You will put on keeping one dog will be there, na? In that you will put keep on putting keys 2, 3, 4, 5 times. You will put key and then you will leave, and after that that toy will start dancing till how much you have coiled it, that many times it will dance, and then again it will stop. Again you will coil it, and again the toy will exactly. So that is a type of spring. When you will tie the spring, means you are storing potential energy in that, and the moment you are releasing it, again it will be exactly starting what you call rotating. In the same way, now in old watch, now not like digital watch, we have to screw the watch. So when we were screwing the watch, good afternoon Manpreet, when we were screwing the watch, na beta, that time we were coiling the spring. So when we were coiling the spring, the energy will be stored in the form of potential energy. Now that potential energy will slowly uncoiling time, it will exactly be used as kinetic energy, and it will allow the what you call minute hand and hour hand to rotate. I hope now, Ashwin, you might have understood. Okay, so it does work by rotating the hands, setting of the toy. That screw toys are there, na, in that one key they will be giving. In that you just have to put the key on that one spring, or one rod will be there. In that you have to put the key and then you have to rotate. Nowadays you all are digital babies. You know, you are playing with mobile, but in olden days, na, that toys were, nowadays I think that toys are also there. So where you have to exactly put keys there, and when you will put key in that, how many times you will put key and you leave it, the dog will dance that many times, and then if you will leave it, it will be. So exactly what happened when you are screwing it, so that time you are storing energy, and that stored energy is the energy in the form of potential. But the moment you will leave it, it will start motion, and the motion of the toy Yeah, I can relate with this. Yes, Manpreet, that one toys are there, na Manpreet. Nowadays, though, we have that battery and all, so we just have to switch it on, and then the toy will be exactly singing, dancing. But that time initially, uh, oh, you were young that time. It was there. Now, to newborn babies, they will have all digital toys. No, no old contents there. Okay, but now spring system will always be exactly storing energy. The springs will be there, na. The spring tying of the spring close together means energy will be there, stored in the form of the energy will be there, and that energy will be exactly a type of potential energy. The moment you will be releasing the spring, na, it will get converted into kinetic. So many times we are seeing, na, gun is there, na, that toy gun is there, na. Why you are first recoiling it? In that, one spring will be there. When you will recoil it, when you will put it back like that, the spring will get coiled. Now it will have potential stored in that, and the moment you will trigger it, the very moment, more toy, where we used to pull the thread and used to tighten the coil. Yes, that was one more and that top was also there, na Manpreet, where we used to take thread and we used to, what you call, tie around the top, and we used to release it, and the top used to rotate. Yes, I recall that one also. One more toy was there. So like that type of games we were playing, but nowadays all digitals are there, so we cannot be able to give proper example to children. So a stretched or a compressed spring will be there now. That stretched or compressed spring has potential energy due to its shape. So when the spring is stretched or compressed, work is done on that. So thus work is done stored as potential energy of the stretched compressed spring. That we have seen now, ki gun example I have given you, that in the gun also recoiling is there. So at the time of recoiling, exactly what happens, the spring will be tied together, and in that energy will be stored, and with what pressure the spring is exactly releasing the bullet, na, or the, what you call, that balls will be there, na, it will be totally depend upon the stretching, recoiling, and with high pressure the bullet will be out, or that balls will be out. So that steel balls are there, na, that is, so that is example. So now potential energy examples: configuration. When the compressed gas changes its configuration, its expand does work. Yes, its expansion is also doing work. Many a times in piston and all, na, so we are compressing the gases. So when you will the piston will be exactly releasing its released, then it will expand the gas will get expansion. So that is again due to configuration. Expansion and contraction of the gas molecules also is due to potential energy due to what you call, its configuration. Potential energy due to its configuration. So I think these many 20 slides are there. So this 20 slides I am going to send you today. Fine. So shall we go for numericals? Get ready everyone for numericals. So now we have understood about spring and everything, na beta. Now also we learned that ki potential energy formula. Then what can be the formula of potential energy? We talked about potential energy due to its configuration. We talked about gravitational potential energy. Tell me the formula for potential energy. Yes, understood now. So can anybody tell me the formula for potential energy? Formula for potential energy, beta. Formula for potential energy, mgh. So that means I already discussed. Yes, Avinash, it is mgh. Work done will be equal to mgh. Absolutely correct. So Avinash, Ashwin, Keshav, Avinash, Manpreet, absolutely correct. Beta, it is mgh. Mg means force. Mg is what? Force. Mg is what? Force. And that means if I am going to take a ball, I keep it at certain height, then the ball is kept at certain height. So Mg will be, this force will be acting downward, Mg, and since it is kept at a height h, so its potential energy will be exactly equal to, Pe will be equal to mgh. So potential energy of an object is due to its position or configuration. Potential energy of an object is due to its position or configuration. Potential energy depends upon weight of an object and height. So potential energy depends upon what two factors? If somebody will be asking you, potential energy of an object depends upon, potential energy of an object depends upon of an object depends upon potential energy of an object depends upon what? Potential energy, height and mass. Yes beta, height and mass, if we will together take one thing beta, mg. So each and every planet will have its potential, so, and because of its gravitational pull na beta, it will be there. So directly we can combine mass with gravitational pull. Directly we will combine mass with direct what you call gravitational pull. So we can say that potential energy directly depends upon, potential energy is depending upon weight of an object. Okay, weight of an object. Potential energy will be depending upon weight of an object. Okay, and second thing is height. So potential energy depends upon height of an object. So weight of an object and height of the object above the ground. Height of the object above the ground. I am just adding this word above the ground so that you can understand that whenever any object will kept at certain height, it will have potential energy. Okay, above the ground or above the surface of earth, whatever statement you can write. So it is totally your call. Okay, so height and weight, absolutely correct Manpreet. Avinash, sorry, mass and weight. Yes, height and weight beta, take ekta. Yes, absolutely correct, take height and weight, that will be more safest one. Why I am saying height and weight? Because yes, mass is one of a factor, definitely potential energy, but the thing here is कि we talk about work and work is force into displacement. Just think like that. So when we talk about force and for vertical displacement when we talk, so force is nothing but mg, and that time when force will be exactly taken as mg, that will be considered as weight. Okay, mass with gravitational pull, acceleration due to gravity, is considered as weight. Mass with acceleration due to gravity is considered as weight. So that's why potential energy depends upon weight and height of the object above the ground. Weight and height of the object above the ground. I just want you all to play safe, so only I told you. Mass, yes, that is mg. Mg means weight. Mg means weight, because beta when a body will have horizontal displacement, then force will be exactly mass into acceleration. But when the body will have vertical displacement, at that time force will be equal to mg. And 100% when I am lifting something and I am keeping it at certain height, that means it is having weight, that is mg. That means it is having weight, that is mg. Okay, now I just want to give you numericals. So two factors we have understood, everyone na, ki what are the factors on which, or on what factors that potential energy depends upon. It depends upon weight and height of the object above the ground. Weight and height of the object above the ground. I hope, is it clear? Okay, weight and height of the object above the ground. Okay beta. Okay, shall we go back to the next point? Yes, absolutely correct. Yes, yeah, my situation is very bad beta today. So now look here, we'll go for some questions. Okay, thank you Manpreet Ekta, thank you for beta encouraging me. I'm totally out. A bag of wheat weight, a bag of wheat is there. It is weight about 50 kg beta. It is weight, its weight is 50 kg, and then calculate the height to which, calculate the height to which it should be raised so that, calculate the height to which it should be raised so that its potential energy is 5000 joules. Now beta, everything is given to you. You can take G as 10 meter per second square. Okay, so everything is given to you. This question, yeah, fever is there Manpreet. It's okay beta, exams are coming for everyone. I cannot take rest because one part of mind will never allow me to take rest. My brain is like that only. First I am thinking about all of you. If I'll take rest, then what will happen in examination? Height is 100. Let's check this one out. Thank you Kanishka, but I'll try beta. Construction, one more video is there, one more video in maths. Today I'll give you one more construction video and then construction part will be over. Okay, so today maths instead of live class, I have sent you the construction. Do it. I think some of you are very active. You have solved and already sent me. I'm very happy. The moment I saw, I was very happy. So all of you, I want you to finish that construction work. A bag weight is exactly, mass mg is exactly given. So weight is given as 50 kg. Calculate. So here weight is mass 50 kg is given. G is exactly 10 meter per second square. Now height we don't know. Potential energy given is 5000 joules. So now formula will be potential energy will be equal to mgh. So potential energy 5000 joule will be mass 50 into g into h. So it is exactly going to be 5000 by 500 equal to h. So this 2 zeros. So it is exactly height will be coming as 10 meter. Height is coming as 10 meter. Everyone pay attention. Height is coming as 10 meter here. Check everyone one more time. Height is coming as 10 meter. If you will cancel, height will come as 10 meter. Okay. Yes, height will come as 10 meter beta. Height will come as 10 meter. So now next one. Next question we are going to do. 10 meter. I took mass 50 kg. Yes, that is what to confuse you now. But whenever you will see one thing, Manpreet, when one small thing is there, I'll tell you. Whenever you will see weight equal to 50 Newton, that time you consider it as mg. That time you consider it as mg, because you know this will nothing be at force. Then that time it will be nothing. That when weight will be written as 50 Newton na, then it will be when only mere kg is there, then you have to consider that this weight is nothing but mass. So there is a way to recognize. Okay, I'm telling you, see correctly, I'm telling you there is a way to, yes, that in the question itself it has been written. In the question itself they have given that the weight is given like this. So they will confuse you. Here they will give you weight, but you have to see the unit. When you will see the unit, it will be crystal clear that here weight is purely mass. Here weight is purely mass, and in this way you have to carry forward. So when 50 Newton is there, that means it is giving mg. When 50 kg is there, that means it is only m. This is the way to understand the difference beta, no matter what statement they are giving. But once you have to pick the content like this, so when they will be giving you mg, it is coming as 50 Newton. I hope my children might have understood this point. Understood na? We'll go for next one. Now this time you see they have given another question. A body of mass 4 kg, they will play with you like this only. Yes, so this confusion comes for everyone. No, weight is exactly given beta. A bag of wheat weight 50 kg. A bag of wheat weight 50 kg. In the question itself, Shruti, it was given. A bag of wheat weight 50 kg. But the moment I am saying a bag of wheat weight 50 kg, 50 kg if I am writing, Shruti, no confusion here. Mass is given 50 kg. But the moment I will say a bag of wheat weight 50 Newton, that means mg together they have given 50 Newton. Mg together they have given 50 Newton. This is exactly, no. Question itself it was given. I'll send you the question. In question itself it was written weight. In question itself it was written weight, and I just said that mass is given. To clarify that time itself I have said that mass is given, so that you should not have confusion related to it. But beta, there are two things. Wherever you will be seeing this difference, Newton written means mg together, kg written means only mass. Okay, because beta Newton is weight. Newton is weight, mg is equal to weight, and then gravitation chapter I already taught you this. Okay, a body of mass 4 kg is taken. No confusion here. My bacha party should never have confusion related to it. Have a clear concept related to it beta. From a height of 5 meter, from a height of 5 meter to a height of 10 meter. Understood, Shruti? Find the increase in potential energy. Find increase in potential energy. Find increase in potential energy. Increase in PE. Find increase in potential energy. So now you have to find increase in potential energy, beta. What will be the increase in potential energy? Ashwin, is it buffering? What will be the increase in potential energy? Fine. Very good. There is an increase of 200 joules. Absolute, beta. This time you have done it perfectly correct. A body of mass. So here mass is given to you is 4 kg. And now the body is exactly taken from a height of 5 meter to a height of 10 meter. So from 5 meter to a height of 10 meter. So change in height is how much? Change in height is 10 meter minus 5 meter. So now the change in height is 5 meter. Okay. Now G we can take as 10. Fine. G we can take it as 10. Huh? Shall we do like that? G we can take it as 10. So now it is exactly going to be potential work done will be mgh. And it will be exactly stored as a type of potential energy. So it is exactly stored as a form of gravitational potential energy. So mass is 4, height is 5, gravity is 10. So it is coming as 200 joules. 200 joules. So exactly this exactly it is a form of gravitational potential energy. From 5 meter we lifted the body to 10 meter. So that means it is stored in the form of gravitational potential energy. One thing is that here work is done against gravity. Here work is done against gravity. When you are lifting some object now, sometimes they will ask this question. I kept one body from height 5 meter to height 10 meter. There will be a work done. But here work is done in favor of gravity or against gravity? What answer you are going to say, beta? Work is done in favor of gravity or against gravity? What answer you are going to say? Work is done in work is done in favor of gravity or against gravity, huh? You are doing work in favor of gravity or against? Yes, this is what we must remember, that we have exactly done work against gravity. We are not putting any negative sign. That's why we are saying we have given a word, and that is called as gravitational potential energy. Why we have not given only potential energy? We have just used a word gravitational potential energy. Gravitational potential energy itself says that a body is kept at a height h. Okay, a body is kept at a height h, and that means it is doing a work against gravity. So there are certain things there we can be exactly capable of explaining the content. Shall we go for next question? I'm just writing it. A shot put player throws a shot put of mass throws a shot put of mass 3 kg. If it crosses the top of the wall, if it crosses the top of the wall, if it crosses the top of the wall of 2 meter high, at a speed of 4 meter per second, at the speed of 4 meter per second, compute the total mechanical energy. Compute the total mechanical energy gained by the short put, gained by the short put, gained by the short put, okay, gained by the short put when it crosses the wall, 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 gained by the short put when it crosses the wall. Take G is equal to 9.8 meter per second square. Take G as 9.8 meter per second square. Okay. Let's see, solve this question, beta. Try solve the question, beta. Try this question out. What and all things are given to you? Ekta 82.8 joule. That was very quick, Ekta. So mechanical energy they told. So what is exactly the formula for mechanical energy? Mechanical energy is kinetic energy plus potential energy. So kinetic energy is half mv square, potential energy is mgh. Half into mass is given as, okay, mass is given as 3 kg, velocity is 4 square plus mass 3 into 9.8. It is kept at a height, it is kept at what height? At what height it is exactly crossing? 2 meter high it is exactly crossing. So it is going to be 2 and this 4 square is there now. So 3 into 16 by 2, 2 8s are 16 plus 3 2s are 6 into 9.8. So it is going to be 3 8 24, 6 8 48, 4 6 9 54, 58, 58.8 to 4.0, 82.8 joule. So total mechanical energy will be 82.8 joule. Yes, total mechanical energy will be 82.8 joule. What doubt? Yes, work is done. 100% work is done. See, work is done now. First it is kept at a height and certain it is having motion. So both kinetic and potential will be there. Both kinetic. I told you again and again one simple thing that it is exactly kept at a height and since it is kept at a height, it is and it is having motion. So both work will be there. Both work will be, that is mechanical energy will be there. Both kinetic and potential will be there. And total mechanical energy will be coming as, Vishal understood now? Here they are not asking you that you are releasing energy and how much work is done according to the external force applied on the bow, that shot put. How much energy is exactly there to let the shot put go, that is what they have asked. So total work done by the shot put is 82.8 since it has been maintained a height of 2 meter. So it will have potential energy and it is having motion. It is having a velocity of 4 meter per second. So it is having kinetic energy. So it will have both kinetic and potential energy. That's it, Vishal. You have to think like that, Vishal. Here it is exactly at a height and it is having motion. So both kinetic and potential energy will be there, beta. So you have to consider both in this case. It is not due to configuration and position. Very good, Vishal. It is not due to configuration and position. It is exactly due to position plus motion both. Here it is due to position plus motion both and they both have to be considered here. I am keeping it till here. Okay. I am keeping it till here. Manpreet, I am having biology class beta. 4:30 heredity and evolution I am going to teach. Heredity and evolution, very important class. It will be there, Manpreet. I hope you might have enjoyed today's class. So 4:30 and after that periodic table will also be there. So I'll just try to teach as much as possible today, yaar.